Hey, in this video we will do a Foobara code demo. You might want to watch the first Foobara video, which explains what Foobara is and what its goals are. It is not absolutely required to watch that to watch this code demo, but it probably would help understand why certain things are being done along the way. All right, let's go ahead and dive in. So what problem should we solve? For this demo, we're going to go ahead and implement an answer bot system. Let's talk really quickly about the mental model of the problem and the solution we will implement. We ask our answer bot a question, it gives us an answer. So very simple mental model. Question in, answer out. So we will have a command called ask. It will take a question and give an answer. We will put that in a domain called AnswerBot, and we will put that in an organization called Foobara Demo. And we will run ask like this, passing it a question and getting back an answer. So here are some requirements for our demo. We will build a front end using TypeScript and React, a back end using Ruby, and we'll use OpenAI's ChatGPT and Anthropic's CRUD as implementation details. So I will give a simplified or oversimplified architecture of what we are about to build. When we're done, I will give a more detailed architecture of what we have built. But for now, just to get our bearings, I'll give an oversimplified architecture, which I think will help understand where we are going. So, as mentioned, we will have a front end in TypeScript and React. This will allow a user to ask a question through a browser and get an answer. We will have a backend implemented in Ruby. We will have a command called ask in a domain called AnswerBot. We will have an HTTP connector, which will expose ask to the outside world. We will import ask into the front end, and this will give us our remote command that we can call, and that will operate as a proxy to our command on the back end. And this is more detailed than necessary, but we will also create an ask form, and that will invoke ask, and that is what the user will be interacting with. All right, so let's dive on in. So first, let's install foob, which is a command line utility for doing all sorts of Foobara related things. And now we're going to generate a Ruby project for the backend. We'll call it AnswerBot, and a TypeScript React project for the front end, and we'll call it AnswerBot Frontend. These will take a little while to run. They're both in the Foobara Demo organization, which will push them up to the Foobara Demo organization on GitHub, which is pretty convenient. It's still not there. This shouldn't take this long. Okay, so now it's up there, finally. So here's the back end. The front end takes a lot longer to build. And we have a test suite running. So there will be 100% line coverage, and it is enforced. It's just a good way to start off a project. If you're dealing with a project with a complicated business domain, you may as well just get started with full test coverage from the beginning, is my opinion, as opposed to trying to bolt it on later. So we'll create an organization called Foobara Demo and a domain called AnswerBot. And finally, we're going to create our ask command. Ask command. Wow. Ask command doesn't sound good. Okay, so we're finally pushed up here, and our build is green. We now have 2 repositories because the front end is up there. And it's running. We can take a look at our commit here so we can see the stuff we just generated. So here's a spec for our command. Here is an organization, a domain, and a command. We'll take a look at this stuff in an IDE, so that's easier to look at and work with, of course. And we'll go look at the front end here, and it is also green. All right, so let's open up RubyMine, and I'll fire up the test suite. Okay. And here we have our command. Here we have some boilerplate. We have a custom error, some dependencies, some validation code. I don't think we need any of this for the demo, so I'm getting rid of it. We need to rename this to question. I'm going to make it required. And we'll have a very simple execute method for now. And we're just going to hard code an answer to I don't know. I don't know. All right. Okay. And I'll add a description here. Ask a question and receive the knowledge you seek. And we'll fix up the spec here. So this should be question. Yeah. And this is hard coded to I don't know for now, so I'll just test that. And it should be green. Oh, we have a bug. Need to rename this to build answer. All right, now we're green. Okay. So now we have our command. We can play with it in a console to see the command interface. We can create an instance of a command with .new. Usually we would not do this, but it is an option. We can run our command with run. That gives us an outcome. When the outcome is successful, we get a result. When the outcome is not successful, we get errors. Here we have our result, I don't know. Here's a way to run it without creating an instance. This is more typical, which gives us an outcome. We can check its result. And if all we want is the result or an exception to be raised, we can use the exclamation form of run. So this is an interface taken from Mutations Gem. So now we'll create a command that has an error. In this case, it's missing the required question. And you can see that it is not successful. And we do have an error that says missing required attribute question. We can look at the errors hash. All right. So let's push this on up to GitHub. Now let's go ahead and expose our command with a command connector. We'll create a command line interface connector. And this will allow us to call our commands from the command line. So here we have our binary. And if we run our binary, we can see we don't have any available commands yet. So we'll go connect a command right now. In fact, we'll just connect the whole organization, which will connect all commands in the organization for convenience. And here we have ask. So we can get help for our ask command. We can see it has a question. And we can run it. We get our answer, I don't know. Let's go ahead and add a description to this for the heck of it, because we can. Say, whatever you want to know. All right, so there we have our answer. There is a form of this that takes just one command. So we could create a ask command line program, but I'll skip that for this demo. All right, let's push this up and let's expose our command using HTTP. We'll use a rack connector. All right, that's generated. Take a look at it here. Get all these files to help us with our rack connector. And here's our rack connector. All right, let's go ahead and fire up our web server here. And let's go play with this. Let's go take a look at the manifest data. And for now, it's only going to have the global domain and global organization, nothing else, because we have not connected any commands to it. We'll just connect the domain again, or the organization, Foobara demo. And now we have ask connected. And it will also contain all this metadata about ask. We will have our AnswerBot domain. We have some errors. We have our Foobara demo organization. Won't go into what processors are, and we get all the types that are necessary in order to implement ask. So we can get help on our command, just like we did on the command line. And we can run our command. And we get our hard-coded answer, I don't know. Nice. So let's run it with an error by removing the required field, the required attribute. And we get our missing required attribute error. Okay, cool. So now I'm going to jump on over to the front end and try to connect it to our backend command by importing a remote command into the front end. So here we have our newly minted React application. And I'm going to go ahead and import our remote commands now. And I can do that with foob, like so, by pointing it at the manifest I want to import from. You can see that it hit the manifest on the left there. Okay, so let's take a look at this. And here is our remote command. Here's our inputs type, possible errors. Our result type is a string. So we get all of the TypeScript types for free. That is really nice. Let's go ahead and push up our remote commands. Now let's generate a form that will call our remote command. And this will create an ask form. Let's take a look at it real quick. So here we are importing ask. Down here, we are running an instance of ask. Here we are building an instance of ask from the inputs. And we get back an outcome. We're checking if the outcome is successful or not, and if it is, we do something with the result. So something very important to point out here is that as much as is possible, the interface here is the same as the interface when we were running the command in the Ruby console. There's some differences. There's a lot of type verbosity in TypeScript that we don't have in the Ruby code. We can't use question marks and methods in TypeScript, but as much as is possible, they are the same interface. And this is very important because this interface is communicating the mental model of our domain. Okay, so let's go ahead and make use of it here. I'm going to put it in the header because I like the formatting of the header. I don't really feel like messing around with it much in this demo. So I'm going to use the ask form, which will call ask on the front end, which will call ask on the back end remotely. We get, I don't know. Cool. Okay, so let's push this up. Sweet. And I forgot to push up the rack connector, so let's push that up. And now it is time to wire this up with ChatGPT. So we're going to go over to OpenAI, take a look at their API here. Let's take a look. Okay, so they have a RESTful API here. They call it CreateChatCompletion. So that really is the command name. That's the mental model we want. We're going to not make use of the RESTful mental model as much as possible here. So we want a command called CreateChatCompletion. Now, one thing we could have done is we could have came into ask and just implemented all the raw RESTful API calls here in ask. But this is not good because then we would be missing our simple mental model of question in, answer out with the much more complicated and confusing mental model of ChatGPT. So what we really want is not only a separate CreateChatCompletion command, but we want a completely different domain. We can just call it OpenAI API. So let's do that. Let's create our domain OpenAI API. And now we can create our command CreateChatCompletion. Cool. Now we have it. Let's go take a look at it. I'm going to delete all this boilerplate again because I don't think we need it. And I'm going to go ahead and implement this command by copy and pasting bits of information from over here. So here we have the inputs, copy that over. All right, I'm just going to start grooming this into our command implementation. So let's extract out the URL, extract out the headers. So I need to convert this curl bash syntax into Ruby syntax. And there we go. And we'll go ahead and interpolate the API token. Cool. Now we need to implement our inputs, which we have here. So need to convert this into the Foobara DSL for expressing inputs. This is one way to express inputs. It's the way that makes the most sense in this situation. So model is a string. We'll just support 2 models for now. That's more than enough for the demo. And we'll give it a default. Our messages is an array, and each message has a role and content. And I happen to know that the roles are system user and assistant, so that's what we'll set it to. Content is a string. Okay. And have a syntax error here. I'm missing an end keyword. There we go. Okay. Cool. I'm going to move this down since this is a helper method. Nice. So we can go ahead and implement our return value now, our return type. So let's grab this response here, copy paste it. We'll just dump it in here and start grooming this into a response type. I'm going to delete all this stuff except for the answer to simplify things. So we have that hello there, how may I assist you? That's the only part I really want. So let's start grooming this into a type. So choices is an array, and it's an array of messages. I'm going to go ahead and make content required and role required. Okay, I'm just going to copy and paste that down here for now. We'll dry that up later. All right, cool. So now we need to implement our execute method. So this really should be a self-documenting algorithm. So I'm just going to pseudocode this up with helper method calls. This is a technique I like to use for all of my execute methods. And again, it's just another way to help with managing domain complexity. And I am going to store everything on runtime context. It's just a technique that I've learned that it helps clean up the command and also helps with debugging and even testing occasionally to have access to all the bits and pieces that were needed to execute the command. All right, let's implement our API token. We'll just grab it from the environment. And we'll build our request body here. We just need the model and the messages, and that's it. Okay, so we're going to grab those off the inputs. That's what model and messages will do there. It'll just use the values from the inputs. Now we will issue our HTTP request. We'll just use the built-in net HTTP library instead of doing something fancier. And JSON. Okay. All right. And now we need to parse our response. Just keep this simple for now. We won't handle any error handling to speed up the demo. And now we're finally going to construct our completion object, which for now will just be a hash. And we're just going to strip out the choices because that's all we cared about was the choices. So we're just going to slice that out of the parsed response. Cool. So now let's test our CreateChatCompletion command, which will fail because we don't have an OpenAI API key yet. Okay, so it's failing. All right, we need to clean up these inputs. So we need a message, or messages, plural. And we're not going to pass in the model because it has a default. We'll give a system prompt here to try to get shorter answers back. It's just something I like to do. I don't like when it gives me back huge paragraphs explaining things when I ask a pretty basic question. And so here we'll ask our question. Let's set our question to, what is the pH of honey? All right. All right, so we should get an error because of the API token, but we got an error because of URL. So there's a typo here. It's right here. This should be URI. Okay. Cool. Okay, so now it is trying to access the outside world and VCR is blocking us. That's perfect. So now let's set up VCR to record this API call. So now we're going to try to record the API call. It's giving me back an empty object, and I think that's because we're not handling the error. I think we need to raise an exception. So I'm going to go back over here, and I'm going to make this a little more robust. I'm going to check if it's an HTTP success. And if it's not, I'm going to raise an error. Could not get completion from URL. All right, that's good enough. Actually, let's throw in the code and the body too. Okay, let's check this out. Let's see what we get now. Okay, you didn't provide an API key. Perfect. So we're right where we expect to be. I need to go generate an API key. So that's over here. And it says legacy. I'm guessing that means it's deprecated, but I'm not going to worry about that for now. So I'll call it foob demo. I'll delete this key later after I upload this. I realize there's a key in the video. I'm going to throw this in a local.env file so it does not get checked into GitHub. And I'm going to go ahead and scrub the API key out of the VCR cassettes so they also don't wind up in the repository and in GitHub, which would not be good. All right, let's try this now. Okay, so looks like we have a bunch of stuff in our result that we are not handling. So we can't get away with what I was trying to get away with here. We actually need to specify these. Okay. I'm just going to set these to duck, which means they can be any type. And that's a concept taken from the Cypress Mutations gem. Okay, there looks like there's a refusal on the message. So I'm going to add refusal duck here. Let's see what else. Oh, we actually got choices. Let's see what we got. Okay, well, it mentions 3.4 to 6.1. Cool. All right, let's take honey. Let's match on honey. So come on over here. Instead of matching on bar, we're just going to match on honey. So choices, the first choice, we want the message and its content, and that is going to match honey. And this should be green. Cool, there we go. 97% coverage. I think we need to cover our raise. So we raise in case of an error, but we're no longer hitting that error anymore. I'm going to go ahead and just exclude this from line coverage for now, and hopefully this gets us to 100%. Okay, cool, 100%. So now the linter runs. Linter is happy. Let's go ahead and push this on up. Cool. All right, let's do some modeling. So if we come over here and take a look at the result type here of this is a chat completion object. Let's go ahead and just create a chat completion model to encapsulate these attributes. Okay, so we've generated a chat completion model. We can cut and paste this on over to chat completion. And we can just set the result to be a chat completion, and that should do it. Okay, so now we have an error because we're doing a hash lookup, but now it's a method call on the model object. So, .choices. All right, that is green. Let's go ahead and keep going. So now our chat completion has choices. We can go ahead and create a choice model. Let's go ahead and do that with all this data here. So let's generate a choice model. And I'm going to go ahead and nest it under chat completion, and that could confuse Foobara or foob. So I'm going to split these up so that it knows what the domain is and what the actual model is. Okay, cool. So let's cut this out of here, put it in choice. All right. And now let's update chat completion. Make use of choice. So we can say it, use some sugar for an array of choices like this. All right. All right, so same issue. It's doing a hash lookup instead of a method call, so we can go fix that real quick. So it's no longer a message key, it's a message method. All right, green again. So we can keep going. There's messages inside of the choices. So may as well just finish this off here. Message is interesting because it was also part of the inputs. So I'm going to put this one at top level instead of nested under the chat completion. And I'm probably modeling this incorrectly, but that's okay. And that's pretty normal. We want systems that we can remodel effectively. But this is good enough for the demo. I'm not going to spend a lot of time trying to nail down the model for the demo. We need to load our model. Message. Okay. Okay, cool. So we get the hash lookup issue again. Let's come on over here and change this to a method call. Okay, it's green. All right, let's play with a custom type. So we've created models, but we can also create a custom type that is not a model. So let's target this role type here in message. So we want to create a type called role. We can do that like this by just specifying a type. And we can cut this. We'll call it role, and we'll specify that it's required in the attributes hash because that's not part of the type. And let's remove required from here for that reason. Okay, so now we have a role type. Let's try running this. And it can't find it, so we have to require the role. Okay. All right. All green and 100% coverage. Let's go ahead and push this up. All right, cool. So now let's make use of our CreateChatCompletion command. So we'll say run AI service because we want to also make this work with Anthropic. But for now, it's just going to work with OpenAI. I'm going to copy and paste this from the spec. And I'm going to go ahead and run the subcommand with the run subcommand method. And let's parse out our response, which is going to be in the choices. It'll be the first choice, and it'll have a message with content. We want that content. And we do need to specify a dependency here. So we'll go ahead and do that. And we need to specify this dependency on the domains. That one should be inferred, but for now it's not currently inferred in Foobara. Okay, it is trying to call OpenAI. So we're going to go through the same process. We're going to record the VCR cassette. Oh, that's amazing. Seems like you're frustrated or confused. Okay, let's change the question to a better question. A less frustrated and confused question. All right, we'll ask again, what is the pH of honey? And go ahead and delete the old cassette, record a new one. All right. So a little bit longer of an answer, I think. It looked like 3 sentences. Anyway, we'll just match honey for now again. And we are green. Our ask command now actually gives real answers. I hate that it is ask command. That sounds so bad. All right, I'm gonna go ahead and get our API key available in development mode, and I'm going to restart the web server by touching the rackup file. Let's try this out. Make you enter a random string of letters. Okay, so what's the pH of honey? 3.4 to 6.1. Nice. Cool. All right, so let's play around with domain mappers. Domain mapper knows how to map a concept from one domain to another, and we're going to use that to get some OpenAI API mental model chunks out of ask. And so first, we're going to generate our domain mapper. And question to create chat completion. So we're going to map from a string to create chat completion, and this means the inputs for that command. All right, let's require create chat completion here, just in case it freaks out over not finding it. Okay, so we can remove this OpenAI API chunk. We can remove that, and we're going to run a mapped subcommand. If I come over here, I can drop this in here, change this to question, and boom, there we go. I'm now mapping a question to create chat completion inputs, and it's green. Push this up. And now let's map from a chat completion to an answer. Let's just copy and paste this, chat completion to answer. So we're just going the opposite direction here. Well, we need to look in the choices. Okay, so we're going from a chat completion to an answer. So chat completion choices, first choice, message content. Okay, cool. All right, that's green. But we're not actually making use of it yet, and that's why it's not 100% coverage. So domain map. And boom, now we're at 100% coverage. All right, so now let's integrate with Claude from Anthropic. I've already implemented the Anthropic API, so that will save us a lot of time in this demo, but I do want to go to their documentation anyway. So there's a quick point I want to make. Which is right here. It mentions if you are using the client SDKs. Point I want to make is if they had used Foobara to implement Claude, they would get the client SDKs for free because you can just import commands and those remote commands operate as your client. All right, so let's see what they call theirs. They call theirs create a message. So CreateMessage is what we'll probably call, well, CreateMessage is what I did call the command. We have a little bit different input and output structure here. So our mappers are going to be different. All right, let's look at the manifest for the Anthropic API that I already implemented in Foobara and pushed up. So we can look at the manifest here. We see our create message command. And has some input types. Result type, which is a message result. All right, we can dig through the help. So we can look at create message and see a little bit of documentation here. This looks pretty crude for now. And we can look at the models here. Here's our message result model. And here's a content model hanging off of the message result model. And yeah, we need to import these models and commands and make use of them. All right, so we can copy this manifest URL and we can use remote imports to import this command. We'll import create message. That's the only command, so we don't have to specify it, but specifying it anyway. All right, so here we are importing create message command. This will allow us to use it just like CreateChatCompletion, even though this is implemented remotely and CreateChatCompletion is implemented locally. All right, so let's go ahead and play around with this. Create message. And it wants a system prompt. So the system prompt is at the top level for Anthropic instead of in the messages. And the messages look real similar. Okay, so create message, run. Specify our system prompt. I'm just going to go steal the other one. Right. And specify our question. Okay, what is the pH of honey? And we got a message result. So let's take a look at our result here. And wow, that's a very long answer. That wasn't concise at all. So I don't know why the system prompt didn't work. Doesn't look like the system prompt had any impact. Let's look at this. Oh yeah, look at that. Wow. So it's even like formatted and stuff. Anyway, I'm not going to worry about that. I'm going to go ahead and push this up. All right, so now we need to add this to ask so that we can choose between either OpenAI or Anthropic. So we'll determine the AI command that we want. And store that here. Command. So let's go ahead and add a service input. And we'll say it can either be OpenAI or Anthropic. And we'll default to OpenAI because why not? Especially since that one was actually concise. Okay. Create chat completion. And create message. Okay. All right. Now let's go ahead and run our command. Instead of a hard-coded command here, we're going to run AI command. Now we need to implement mappers for Anthropic because we don't currently have mappers. We only have mappers for OpenAI. So it's going to fail. All right, so I'm just going to copy and paste the existing mappers. And I'm just going to start changing these to Anthropic's mental model. So it was a message. So we're going to go from a message. Okay, and then it was content. And it was the text. Anthropic API. Okay, so we're going to map to the CreateMessage inputs. Cool. We'll change this to system, and then we only have one message now. All right. Okay, delete the import. So now we need to fix the file names. Well, we don't have to, but we really should. So let's do that. Message to answer, and then it's going to be question to create message. Okay. And actually, it's not a message, it's a message result. So let's fix this. This is broken. It's a message result, not a message. Okay. All right, so now let's run this again, but hitting Anthropic instead of OpenAI. And it's actually hitting our service that we uploaded to Foobara.com instead, which is then operating as a proxy. So we don't have to worry about the API key. All right, so let's see this. Okay. Oh, we forgot the dependencies. So let's go ahead and add a dependency. This depends on CreateMessage. All right, cool. It's trying to hit VCR. Hopefully it's hitting VCR for our playground and not OpenAI. Oh, look at that. Green. Let's go take a look at the cassette, though, just to make sure that it's hitting the playground. And it is. Playground.foobara.com. Excellent. And there's our oversized answer. Cool. And Linter is happy. 100% coverage. Let's push this up. All right, so let's regenerate our remote commands in the TypeScript front end. Since we changed the interface, we added that service input. And oops, CreateChatCompletion should not be in here. So we are exposing more than we need to. So let's just make it a little bit smaller here. We'll specify the answer bot domain. And this should be smaller now. All right, so we've regenerated our command. We've regenerated our form. See our inputs had service there. And let's try this. Now we have a service picker, pH of honey, 3.4 to 6.1. Anthropic gives us this. Ooh, it's the same answer, but it's just much longer. All right, let's push up our updated form and our updated command, or updated remote command. Let's push our HTTP connector, and now let's play around with persistence. So we're going to add a Redis CRUD driver. So this is going to be our first CRUD driver. It knows how to read and write entities to a database. So if we look at CRUD here, we are setting up a Redis CRUD driver. So let's go ahead and generate a entity. And so let's go ahead and log all of our question and answers. So we'll call this a question log entry, just to come up with something that needs to be persisted so we can play around with entities. All right, so we've generated an entity. It's like a model, but has a primary key and can be persisted. So here we are, question log entry. Let's go ahead and add question here, and we'll say questions required. Let's add answer, and I'm not going to make answer required because maybe we want to log this in case of a failure, in which case we might not have an answer. And we'll store when we asked it. All right, so let's run the test suite. Oh, we need to set up Redis, so we need to uncomment these. They're commented by default for safety reasons. Okay. All right, so let's log our question. And we'll specify a dependency on question log entry. This would normally be inferred if it was an input or a result or part of it, but it's not. So log entry, and we'll just create a question log entry. Okay, and so this will be written to Redis when the command's transaction closes or commits. And there is so much we could say about entities, but that will have to be its own presentation. So we want to make sure that we create one. So we're going to make sure the count goes up by 1. And what do we have here? Oh, we need a transaction. We don't have a transaction. So we need a transaction to check the count of the question log entry. So we'll just open a transaction here. We need to fully qualify this. Sweet, it is green. So we are creating our question log entry. All right, so let's create a command to read our question log. So we'll call it read question log. We'll just use this for convenience in a console to test the upcoming stuff we're about to build. Right, it doesn't have any inputs, but it is going to return a question log and some basic behavior here. We'll just load it and sort it because why not? Log entries. Okay, we'll get all of them. We'll go ahead and sort the log. We'll sort it by AskStat so that they're in chronological order. All right, I'm going to be lazy here and I'm not going to initialize any question log entries. So an empty array is good enough. All right, let's play around with read question log entry. Let's run it. And there are no questions. Let's try asking again. There we go. So you can see there's our answer. All right, let's ask it what's an example of an interesting question. All right, so let's see. Quantum entanglement. Yeah, that I think is interesting. Okay, so now let's create an asynchronous connector. We'll use a rescue connector. This will allow us to run commands asynchronously. So we're going to try to ask asynchronously what an interesting question is. So let's look at our commands here. We have ask, read, create. Now let's go ahead and connect to our rescue connector, the ask command. And now we get an ask async command. So this command will run asynchronously. So let's play around with that. Here's ask. Let's ask what is an example of an interesting question. Okay, and now let's ask asynchronously. So instead of getting back an answer, we just get back true. And let's go ahead and look at all the answers. And now what we're going to do is run a worker to actually process our asynchronous ask call. And wow, we've gotten quantum entanglement 3 times in a row. That's impressive. All right, so now let's generate some scheduler code. This gives us kind of a cron job for our application, pretty typical thing to need in a lot of applications. And we'll ask the same question, but we'll ask it every 5 seconds for demo purposes. So let's come on in here to cron. We'll go ahead and connect ask. Clean this up here, and we'll pass in the inputs separately. Okay. And let's Let's get rid of this. Okay, and we'll run it every 5 seconds. Oh, every 5 seconds. Okay. So now let's run our scheduler. It should show up in our proc file now. It does. Let's go ahead and run this. Okay, so there we go. It already processed it once. So quantum entanglement, again, 4 times. I guess that's the only interesting question. Is that 5 times? Yeah, that's 5 times. I don't know if that's 5 or 6. Oh, discovering microbial life on Mars. Okay, microbial life on Mars. Still science-based, but at least it's biology instead of physics. Okay. Cool, and let's see, understanding. Another quantum. Oh, here's one on cryptography. So we got cryptography and then back to quantum entanglement. So that concludes our Foobara coding demo. It was long, too long, really. Sorry about that. And the presentation has not concluded. So apologies in advance, but this will go on. As mentioned earlier, I do want to reflect on everything we built, discuss its architecture, and discuss some of the benefits of Foobara, particularly in relation to managing domain complexity. So what have we built today? Well, we first had a backend system in Ruby called AnswerBot. Inside there, we added an AnswerBot domain. We added a command called ask. We added a command line connector and connected ask to it. And this allowed us to run ask from the command line. Ask was hard-coded at this point to answer every question with I don't know, which isn't particularly useful, but it did function. We then added an HTTP connector, connected ask to it, and preemptively, we had actually created another system in TypeScript using React called AnswerBot Frontend. We were then able to import ask into our TypeScript code and the whole AnswerBot domain. We then generated an ask form, which makes use of that metadata we had talked about. And this allowed us to run ask from a browser. We then, in order to give real answers to our questions, added a domain called OpenAI API. We added a CreateChatCompletion command. Its responsibility was to actually consume the OpenAI RESTful API. And we made use of it from ask. And so this allowed us to now get real answers to our questions. We then went ahead and did some modeling. We extracted some models from the inputs of CreateChatCompletion and from the result of CreateChatCompletion. The ... here just symbolizes that there's many models involved. We then added a domain mapper that knew how to map the question concept from the AnswerBot domain to the CreateChatCompletion inputs in OpenAI. I'll come back and talk a little bit more about the domain mappers a little bit later, but just an optional technique Foobara provides for helping with domain complexity management. So then we made use of our domain mapper from ask. This allowed us to relocate some domain logic that was related to the OpenAI domain out of ask. So then we added a domain mapper that knew how to map from a chat completion concept in the OpenAI domain to the answer concept in the AnswerBot domain. We made use of it from ask. Now this allowed us to move even more OpenAI related mental model code from ask into a domain mapper, further simplifying ask and making it focus more on the OpenAI domain. Now preemptively, I had implemented an Anthropic API domain. I had pushed it up and exposed it with an HTTP connector. So in order to fulfill our requirement of supporting either OpenAI or Anthropic's CRUD, we went ahead and imported CreateMessage from the Anthropic API along with the models from Anthropic API. And we went ahead and added our domain mappers to parallel what we had done with OpenAI. So we had a message result to answer mapper, and we had a question to create message inputs mapper. And these again know how to map the concepts from the AnswerBot domain to the Anthropic API domain. And then we wired it all up with Ask, and this kept some of those Anthropic API domain concepts out of Ask. Okay, so then we were able to choose a service we wanted to perform Ask with. And we were able to add, because of the domain mappers, we were able to add CreateMessage support to Ask. We were able to add Claude support to Ask. And we were able to add the service input to Ask, which is part of the AnswerBot mental model, without adding very much Anthropic API mental model code to Ask. So that was pretty cool. And hopefully you noticed that and can see how that can help with domain complexity over time. So then we added a CRUD driver, in this case a Redis CRUD driver, which knows how to read and write entities to and from Redis. We added a question log entry entity, and we started writing these out from Ask. We then added a read question log command, and this was for convenience so that from a Ruby console we could actually look at the question log. We did this because then we added an async connector, connected it to Ask, fired up some workers, and we were able to run read question log in a Ruby console after having ran Ask asynchronously, and we saw that it did actually get answered asynchronously. Then we added a scheduler connector, connected Ask to it, specifying it should run every 5 seconds. We fired up a scheduler, and then again, in our console, when we ran read question log, we were able to see that every 5 seconds it asked our question. In this case, it was, what's an example of an interesting question? It was overwhelmingly quantum mechanics related for some reason. That's interesting. So that's everything we built today. It's a lot. We also had 100% line coverage, which probably was not a good idea for the demo, but regardless, we got 100% line coverage. And I want to now discuss a few aspects of the resulting architecture here and just what we built and how we built it. So something worth pointing out is that we only implemented the pieces that are in color here. So commands like ask and CreateChatCompletion. We implemented domain mappers that knew how to map domain concepts in one domain to another. We implemented models and entities, and we even implemented a custom type, which I forgot about. That's not reflected here. But we did not implement any of these other pieces that are not in color. And what's important about this is not so much that it saves time to only have to write some of this instead of all of it. The pieces that we are writing are actually related to the domain, to the problem we're trying to solve, and the proposed solution to that problem. We're not writing integration code. And this is important because it means that we are not tangling up our domain logic with our integration code. We have nice, clean domain logic that is reusable in a variety of contexts. And along those lines, it's important to point out here that CreateChatCompletion is implemented locally, but CreateMessage is implemented remotely. Now, the very important thing about that is we could change this so that CreateMessage is implemented locally and CreateChatCompletion is implemented remotely, and we wouldn't have to refactor a single thing at all in the AnswerBot domain. And that's because the interfaces between these commands do not change based on their integration context. The interfaces stay the same. Hopefully you can see how this could help with re-architecting systems. And I think that's very important because a lot of times a system gets mismodeled. It's inevitable. If you have a complicated business domain, you will mismodel the system. It's very important to understand that that is going to happen and is inevitable. And so you want to have an incremental path forward to improving the modeling in the system, as well as the architecture of the overall system. And this tries to help provide that. It might look like a glaring architectural flaw that there is an inconsistency between OpenAI being local and CreateMessage being remote. And I would agree that it would be an improvement to make those consistent. But the thing to point out here is that being in a state where that is inconsistent is nowhere near as painful in this project as it would be in other similar projects, because in those projects, in order to rip this piece out, you would have to do some serious refactoring to detangle it from the rest of the system and pull it out, and you would have to test all of that. Here, that is simplified significantly, and in fact, Foobara provides a script called extract repo, which will take this OpenAI API domain and extract it out into its own repository, preserving the Git history, and that would allow us to just import this as a library relationship, or we could then push it up somewhere and expose it with an HTTP connector if we wanted to. So what I want to point out here is that we can fragment and combine these into different projects, repositories, however we like, without having to do large refactors with testing that those refactors are not actually introducing regressions. That is very important. So hopefully you can see how that would help with managing domain complexity. Now, I had mentioned that I wanted to come back and talk about the domain mappers, but we talked about them as we were laying them out, so I'll try to be quick since this is running really long regardless. But as we added these, when we added this domain mapper, we were able to remove a significant portion of code from Ask that was dealing with the OpenAI mental model. We were able to remove that from Ask. And we were able to remove the last non-trivial piece of it when we added this domain mapper that knew how to translate a chat completion to an answer. This left the ask command dealing with questions and answers, which are concepts in the AnswerBot domain, and not dealing with things like chat completions, which are concepts in the OpenAI domain. This means that an engineer tasked with changing some behavior in Ask can go in there and not have to see anything related to the OpenAI domain. The only thing they're going to be able to see is that Ask depends on the OpenAI domain. And we did have one little piece of code that knew how to switch between CreateChatCompletion and CreateMessage based on the source that we chose. We could have created a domain mapper that mapped from source to either CreateMessage or CreateChatCompletion. We didn't do that, and I think that's fine. But the point being that an engineer can go in and work on Ask and would only have to have their mind in the AnswerBot headspace, not the OpenAI headspace. And hopefully you can see how, again, that will help with better mental models, better domain management complexity, and not just better mental models, but better mental models across the organization, better communication. Hopefully people are discussing things more in terms of high-level business operations as opposed to low-level tech stack decisions. Another thing I want to point out is that if OpenAI had implemented CreateChatCompletion using Foobara, we would not have had to write this at all. We could just import CreateChatCompletion and use it in Ruby, or we could have imported CreateChatCompletion and used it directly from TypeScript if we wanted to. And so hopefully you can see how if you're building a large network of these systems, how that would also help with domain management and complexity, because now people are not spending time writing a one-off client just to invoke a high-level domain operation that lives in a different system. And there's a lot of stuff that I would want to say about CRUD drivers, in particular using custom CRUD drivers for additional flexibility to help with remodeling and re-architecting systems. But I think we're already at around the 1 hour mark, so I should wrap this up and say goodbye for now. Can always cover more stuff in other videos. But yeah, if you made it this far, I'm impressed. This is long, unacceptably long. And thank you for listening all the way to the end. And yeah, thank you. Peace.